Let's figure out, so you guys, I know like when it came to figuring out all of the radians, hopefully you guys saw that there was a little pattern that kind of took place. So the same thing's going to happen. We're going to right now in our little lesson, we're going to focus on where to get the points in this first quadrant. And then once we know the points in the first quadrant, then we can sit there and see if we can find the pattern that fills in all the other 3 quadrants on that. Sound good? All right. So we got section 4.2, and we'll put an A on this one since we'll spend a couple little days on it. And we're just going to be working on the unit circle. So I'm going to give us a nice big circle, or a decent sized circle, hopefully. Woohoo! Look at that. And we got our Y. And we got our X. And that's going right through the center of the circle, right? And then since we know that we're on the unit circle, we always have a radius of 1, right? And we even figured out what that point was on our unit circle. So if we went from the origin right to here, we knew that that was the point 1, 0, right? Because our radius was 1, we went over 1 and we didn't go up or down any. So I'm going to say that this is my little terminal end. And I'm going to say that this is our 30 degrees, right? Perfectly drawn 30-degree angle, right? And so we can see like on our terminal side crosses through our circle, right? And it crosses through our circle right at this point. And we want to be able to figure out what that point is on the circle. Sound good? So we know that our radius is 1. So we know that this distance from the center of the circle to this point is a distance of 1, right? And if I wanted to, since I know that my x-axis is that nice little flat line, I could drop down a perpendicular line, and actually I should use my little line tool, shouldn't I? If I drop down a perfect little perpendicular line, a perpendicular line always makes a 90-degree angle, right? And then now I just created a 30, 60, 90-degree triangle, didn't I? Right? Because this one up here now be 60 degrees. And I'm just going to redraw that triangle a little bit bigger off to the side, just so we can see it a little bit better. Hey, that was pretty slick, wasn't it? So what do we know? We know that this was 1, and we know this was 30 degrees, and this one was 60 degrees, right? So do we remember how to figure out 30, 60, 90-degree triangles back from back in the day when you guys were in geometry class? There was little formulas when it came to 30, 60, 90s. Or you could use trig even, right? But if you remembered the formulas, like the short side, we always refer to as x. The hypotenuse, we always refer to as 2x. Anybody remember what the long leg was? X times the square root of, extra credit if you know it, 3. Remember all those little special right triangles that you guys had to learn, right? Now it's going to come back and haunt you. We only got to do it like 3 times, well, sort of, and then we're good, right? Then we got them all figured out, right? So ultimately, I need to figure out what my long leg is, and I need to figure out what my short leg is. because this is going to tell me how far I go over on my x, and this is going to tell me how high I go up on my right, right? So I know that my hypotenuse, which is 2x, equals 1, so I bet you I can solve it for x, right? So what do we know? That 2x equals 1. Whoops, that's a nasty 1. So x is going to equal half. So we know this side equals a half, right? And then we can figure out our long leg because we know what x is, so we're just going to plug x in. So this is 1/2 times the square root of 3. So just to make it nice and pretty, I'm just going to like throw that over 1 and make it the square root of 3 over 2. We good on those? So let's see if we can figure out what our point is then. So to figure out this point is just an xy coordinate point, right? So x is going to tell me how far I went over. Well, how far did I go over? Square root of 3 over 2, right? So my x coordinate is going to be the square root of 3 over 2. How high did I go up? How high did I go up? 1/2. Half, yep, absolutely. So my y coordinate's going to be 1/2. So now on our unit circle, we know that for 30 degrees, our x coordinate is the square root of 3 over 2, and our y coordinate is 1/2. So we can use that. I wonder, is it here? Oh, it does. Yeah. We can use that same thought when it comes to making a 45-45 degree angle. Right. Ooh, that was bad. Right. We got our little unit circle. We got our x and y axes. Whoop. Since it's a unit circle, we know that that's 1, 0. Right. And we're going to use that as our initial side. And then now we're going to do a 45 degree angle. And we want to figure out that point. And we know that our radius is going to be 1, right? If I drop down that little perpendicular line, I make a little 90-degree triangle. So I'm just going to redraw the triangle over here just to make it a little bit bigger. And we knew that our radius was 1, so I'm going to throw that in there. And if this angle is 45 degrees, what do we know about the other angle? It's 45 degrees, right? Because it's a right triangle. Triangles add up to 180. And what do we know about our two sides, our two legs? This leg and this leg. What do we know about these two legs in a 45-45?
Aren't they the same?
Yeah, they're the same. They're equal, right? So we can call those guys x. And anybody remember when it came to like solving that little formula? Or we could use Pythagorean theorem, right? X squared plus x squared equals 1 squared. And we knew that this was x times the square root of 2. Right? So we can solve it from x by looking at this guy. So we know that x times the square root of 2 equals 1. Divide by the square root of 2. And x equals, whoops, 1 divided by the square root of 2. But sometimes our little fancy fancy mathematicians, we don't like those radicals in the denominator. Remember that? So in order to get rid of that square root of 2 in the denominator, we multiply the top and bottom by the square root of 2. So that's going to give me what? The square root of 2 over the square root of 4. And what's that going to reduce to? The square root of 2 over 2. So this side of my triangle is the square root of 2 over 2, and this guy is the square root of 2 over 2. Think we could figure out our point?
Yeah.
Yeah. How far did we go over?
Square root of 2 over 2.
Good job, yep. Square root of 2 over 2. And then how far did we go up?
Square root of 2 over 2.
Look at you. Good job. So then back on your little unit circle, we can fill in 45, right? Square root of 2 over 2 and square root of 2 over 2. So we got one more to go, right? So it's almost going to be like our 30, 60, 90 that we did first, right? Make a nice little circle. That's not a circle. Nice little circle. Get your X and your Y. And now we're going to go 60 degrees. We know that our radius is going to be 1. We can drop down that little angle, make a 90-degree angle. We know this guy is 60, and then this one up here is going to be 30. So I'm just going to redraw it to the right. And we knew that this one was 60 degrees, and this guy up here was 30 degrees. Our hypotenuse is still 1. Right? When it comes to 30, 60, 90s, we know our short side is x. Our long side is x times the square root of 3. And our hypotenuse is 2x. Right? So we actually already went through and kind of solved this, right? So we know that our hypotenuse was 2x and that equals 1. So we knew that our x equaled 1/2. So this side is going to equal 1/2. Ooh, I'm going to sneeze. And then so we know that our long side, is going to be 1/2 times the square root of 3. And we just kind of simplify that down to the square root of 3 over 2, right? Same thing that we did on that very first one. The only thing is difference is the distance that we're moving. So now we know that we're moving over a distance of 1/2. So our x is now 1/2. And how far did we move up? Square root of 3 over 2. So now our x is 1/2, and our y is the square root of 3 over 2. All right. So let's see if we can kind of figure out some of our other points when it comes to our unit circle. We know how this degree is like 30 degrees. If we think of symmetry and we switch over or flip over our y-axis, Does that represent like another 30-degree angle? Yeah, right? Does this kind of like represent like a 45-degree angle? Just flipped over the y-axis, right? And this would be like 60 degrees flipped over the y-axis, right? So when it comes to our coordinate plane, only thing changing is our signs, like on our x's and our y's, right? If we're in this first quadrant, we know that our x's are positive and our y's are both going to be positive, right? Well, if we're in the second quadrant, is our x going to be positive or negative? Negative, and our y is going to be positive. So these points are going to be the same thing, except what's going to happen with all of your x values? They're all going to be negative. Yep. Boop. And then the only thing is being a little bit careful when you go to flip these over the x-axis, because this point is going to flip to this point, right? Some people make the mistake and they just take all three of them and they almost just like shift it down to where they associate this point with this point, right? This one with this one, which is fine, but then this one with this one, right? So you got to think of though you're reflecting it. So if I reflect it over this line, this guy is going to go to here, right? And if I'm in my third quadrant, we just got to think about this. Are my x's going to be positive or negative? Negative. Are my y's going to be positive or negative? Negative, right? And then the same thing when it comes to my x, or my fourth quadrant. In my fourth quadrant, my x is going to be positive. My y is going to be negative. Yep. Not too bad. So we do kind of try to get to the point eventually to where we have like these points memorized. But once we have the points in the first quadrant memorized to where you could write them down, you could figure out the other three quadrants, right? So some of the tricks that we kind of go through, like the 45, I think that's the easiest one because it's just that square root of 2 over 2 times the square root of 2 over 2. A couple little tricks. Well, let me erase these ones. Is we know that everything is a fraction over 2. Do you notice that? All of your denominators are 2. So you can go ahead and fill in all of like the little 2's, right? And then there's this little trick where you start up at the top and you write a 1, a 2, and a 3. And then when you go to your y's, you go 1, 2, 3. And then you just have to put square roots in your numerator. But the square root of 1 is 1, so you don't do that, right? Square root of 3, square root of 2, square root of 2, square root of 3. And we know the square root of 1 is 1. So there's always kind of that thing where you just do the 1, 2, 3, the 1, 2, 3. The other thing I kind of do sometimes, like if I can't remember, well, do I start with the one up on the top or do I start with the one at the bottom? I kind of even draw them out, kind of a little cheesy. Like when it comes to my 30-degree angle, right? And here's my point. And I'm like, well, does my half go on my X or does my half go on my Y? I kind of just try to think of it when it comes to my X and Y axes. Like, because if I drop this down, like, is that halfway across the X axis? No. But if I take it over to the Y, is that like halfway up my Y axis? So then I know that my Y is going to be half. Right? Same thing on the 60 degree. I like to find out where my half is. If I drop that straight down to my x-axis, I can tell that that's halfway to 1, right? Where if I brought it straight across to here, I'm way above halfway. Does that make sense? So sometimes I do it that way to figure out where that half goes. And then if I know where the half is, then I know where the other one's square root of 3 over 2. So it takes a little bit of practice and a little bit of figuring out a way to kind of remember. That way you don't have to always go through and do the triangle, right? Sound like a plan? So now, since we know all of our points on our unit circle, or at least not all of them, but our little standard ones that we've been messing with, we can actually use some trig functions to kind of figure out what's going on with all of these. So there are technically 6 trigonometric functions that we're going to mess around with. Oops, that's the wrong color blue, isn't it? So in these we all use we just say that our point, whatever point on our xy axes is that xy, right? So for point P, so these are all for whatever point is on our unit circle going around our unit circle. So if we had our little circle, we got our little x and our little y, right? So I don't know, let's say we were looking at this angle. Let's say this is our angle T. And this here would be my point. This is my XY. And we know since it's the unit circle, that's that point 1, 0. So our first little trigonometric function is cosine. Oops. And it's going to be cosine of t. And that's just going to be our x value. After cosine is, starts with an S. Sine, yep. Our sine of t is going to be our y value. And our tangent of t is going to be y over x. I know you guys aren't completely new to sine, cosine, and tangent. You've kind of seen those a little bit. And then I like writing these right next to these. So from cosine, there is this one called secant. I guess I should have wrote these out. Secant of t, and that's just our 1 over x. So it's the same thing as like 1 over cosine. There is secant of t, which is 1 over y. And cotangent of t, which is x over y. So we can write these out, right? So COS is our cosine. Sin is our sine. Oop, let me get that little arrow out of there. Tan stands for tangent. Good job. That SEC, it's not the football like the Southern Division. They rule. Woo, woo, woo. Sorry. That's secant. CSC is cosecant. Somebody took a lot of time to come up with these names. And COT is cotangent. Right. You guys good? So now what they're going to ask for you guys to do is they're going to give you a point that's on that unit circle, and then they're going to want you to find the 6 trigonometric functions for that point. So I'm going to get you guys a clean little screen. Oops. So let's say here's our little circle. And our little initial side, we're going to go. We knew that that was the point 1, 0. We're going to go for that positive angle of t. And I know that this point is going to be, let's say, negative 1/2 and the square root of 3 over 2. So if I now go through those 6 little trigonometric functions, so the first one was the cosine of t. What's cosine represent?
X.
X, yep. So what's our x value?
Negative 1/2.
-1/2, yep, you guys got it. Yep. Then they're going to want you to find sine. Sine is our,
Y.
yep, and what's our y?
Square root of 3 over 2.
Square root of 3 over 2. Tangent of t is,
And then Y over X.
yep, y over x. And if it helps, actually write that out, right? Y over x. So then now we can do, what's our y?
Square root of 3 over 2.
Yep. Square root of 3 over 2 all over our x, which is
Negative 1/2.
-1/2. You guys remember how to simplify fractions? Or when we're dividing fractions, what do? Multiply by the reciprocal. Yep. So this would be the square root of 3 over 2 times. I'm going to throw my negative out front. It doesn't matter where you throw it. I'm just going to throw it out there. And what's the reciprocal of 1/2? 2 over 1. Yep. Do my 2's cancel? And I have what? Negative square root of 3? So that would be my tangent. What was next on the list? Secant. Yeah. Now we're going to get into our fractions. Right. So secant of t, that was like 1 over x, right? So that's going to give us 1 over, what was our x? Ooh. Negative 1/2, right? So we got to multiply by the reciprocal. So 1 times, what's the reciprocal of negative 1/2? Negative 2. So the secant of t is going to be is -2. Then there was cosecant of t, and that would have been 1 over y. So it'd be 1 over the square root of 3 over 2. I'm going to slide this up a little bit for you guys. Okay. So I got to multiply by the reciprocal. So the reciprocal of square root of 3 over 2 is 2 over the square root of 3. So that's going to be 2 over the square root of 3. But we can't leave square root of 3 in the denominator. So we're going to multiply top and bottom by the square root of 3. So you add, what, 2 times the square root of 3. Square root of 3 times square root of 3 is the square root of 9, which is?
3.
Good job, 3. Okay. And then we got one last one, right? Cotangent. So then the cotangent of t was x over y. Our x was -1/2. And then our y was square root of 3 over 2. So we're going to multiply by the reciprocal. Which is going to give us what? -1 over the square root of 3. Can't leave that square root of 3 in the denominator. So multiply top and bottom by square root of 3. So we get negative square root of 3 over square root of 3 times square root of 3 is 9, which is 3. Weren't those fun? So then you found all 6 trigonometric functions for angle T. The only other way like they might give you guys these is they're going to ask you to find out what it is for if they're going to leave it like in the radian. So let's say they gave you just the sine. The sine of pi over 6. We know that the sine is looking for which value? Y, right? So if we're looking for sine, we're looking for the y, right? And so they want us to know the y value when our angle is at that pi over 6 or when our radian is pi over 6. So this is where your unit circle comes in handy. Because now we can go back to our unit circle. Whoops, and I didn't fill in the radians. Where's pi over 6? How many degrees?
30.
30 degrees, right? So now that you know that pi over 6 is your 30 degrees, what's the sine value? Which is our y, which would be 1/2. So then you know this is going to equal 1/2. Then you're only finding one of the 6 trigonometric functions, right? You don't have to find all 6 of them if they ask you just for what the sine is.